This lesson deals with Supplemental Problem 3.1. You can find this problem in the ECE302 ebook in the Chapter 3 Supplemental Problems, starting on page 1. In an attempt to repair an amplifier, the following node voltages were measured on several NPN transistors. Indicate the state in which each transistor appears to be operating. According to the manufacturer's schematic, all three transistors should be in the active region. Which transistors indicate that something is not working correctly? The solution to this supplemental problem is based on a book by John Link called The Handbook of Practical Solid-State Troubleshooting. And what he recommended was to measure the base emitter and base collector voltages because voltages are a lot easier to measure than currents. With current, you have to break the wire. Let's do that. Let's measure each of these transistors' base emitter and base collector voltages. Here's the first transistor. I've labeled the collector base emitter, which had a voltage of 4.2, 4.7, and 4 volts. The base emitter voltage is 4.7 minus 4, and that's 0.7. And the base collector is 4.7 minus 4.2, and that's 0.5. Let's go back to Chapter 3 on page 1, where we had some data for a typical NPN transistor. You can see here when we're forward biased, the base emitter drops around 0.7. That means this is about 0.7 volts when it's forward biased. Now when we're operating in saturation, the voltage across here is approximately 0.2 in this example, and it's typical of an NPN transistor. But when this is occurring, this junction is forward biased. Just doing the algebra here, the rise in voltage would be 0.7 and the drop would be 0.5 plus 0.2. Although it's not shown on this set of curves, the forward biasing of the base collector junction when you're operating in this first quadrant is typically around 0.5 volts. So the base emitter and the base collector are both forward biased, and that would indicate that the transistor is saturated and not in the active region. Here's the second transistor, and again I've labeled the collector base emitter, which are 6 volts, minus 7.7, and minus 8. The base emitter is minus 7.7 minus 8, and that's 0.3. And the base collector is minus 7.7 minus a plus 6, and that's minus 13.7. This is clearly reverse biased, but here we have a voltage that's positive, but it's not large enough to forward bias the PN junction. So you could think of reverse biasing as also being not forward biased. And cutoff. Here's the last transistor, and redrawn. I've again labeled the collector base emitter, minus 2, minus 7.3, minus 8. The base emitter is going to be minus 7.3 minus a minus 8, and that's 0.7. And the base collector is minus 7.3 minus a minus 2, and that's minus 5.3. The base emitter of this transistor appears to be forward biased, and the base collector appears to be reverse biased. And so this transistor is in the active region. If we have a repair problem, I would look at transistors 34 and 19 as being the source of our problem because they're clearly not in the active region. And this is Supplemental Problem 3.1.